Allah Subhanahu wa Ta'ala, who has given us the blessing and guidance so that we can gather here. And I ask you to deliver your prayer and greeting to our Prophet Nabi Muhammad Sallallahu Alaihi Wasallam, who has brought us to the dark age, from the dark age to the age light. Okay, on this blessed day, I'm Puspa Rahmawati, and my ID number student is 18101098. Will present a topic of my research project regarding Lorawan, and the title is Lorawan Network Planning at Frequency 1920 until 923 MHz for electric smart meter in Karawang Industrial Estate. Okay, outline. In this presentation of the seminar proposal, there are several outlines that will be discussed. For the first, background, problem formulation, scope of problem, purpose, benefit, basic theory, flowchart, final project schedule or timeline, and reference. Okay, background. Background is the underlying point of a research. In the background, there is a problem, and the problem then is raised to find a solution. In this Lorawan research, the background starts from development of technology. Okay, the rapid of development of technology, making technology an important need for many people, where technology is used in the field of industry, education, agriculture, health, security, and other fields. Okay, with the development of technology, allow many new technology can be created and very useful for many people. One as a new technology is Internet of Things. Internet of Things, or IoT, was developed to support human activities to be more effective and efficient to minimize the work of human beings. Application from IoT also be used to monitor several aspects, such as electrical energy. Okay, why electrical energy monitoring is important? Because electrical energy is one of the energy that is often used in daily life. According to the statistic of the State Electricity Company, or PLN, in 2013, the industrial sector with the number of customers only ranked from 0.1% of total customer, its electricity consumption reached 31.59% of the total consumption. Okay, for example, one of industrial area with large electricity consumption is in industrial area in Karawang, with usage reaching 2,210,603,000.798 kilowatt-hour during 2019, cumulatively up to June 2019, from a total of 3,million,304,000.182 kilowatt-hour of electricity used in Karawang. Okay, with the problem of large of electrical energy, a monitoring system is required by using electric smart method. To avoid and overcome the excessive use of electrical energy and affect the production budget, the solution used is to apply smart metering. To maximize the use of smart meter in required to design the LoRaWAN network as a LoRa protocol on the coverage and capacity to know how many gateways are needed as a means of communication between sensor and server in the process of sending data. Okay, there are four problems obtained from the background. For the first, how to calculate link budget using Okumura-Hata propagation model to get the estimate number of gateway need based on coverage and capacity planning in Karawang Industrial Estate. Okumura-Hata propagation model is used to determine path loss in the frequency of range 150 MHz to 100 to 1500 MHz. Number two, how to calculate use demand for IoT device per day and total packet on gateway 8 channel to calculate the estimate number of gateway based on capacity planning in Karawang industrial area. For number three, how to design long-range wide area network using Atoll software 3.3.2 according to calculation of time. And number four, how does Lorawan network performance based on the parameter use are spreading factor, code rate, bandwidth, signal to noise ratio or SNR, and receive signal strength indicator or RSSI. Okay, for the next scope of problem. For number one, Lorawan design is focused on coverage planning and capacity planning to know the estimate number of gateway, note the design of smart meter tool. For number two, Lorawan design is focused only on existing industrial area in Karawang, not on the entire Karawang area. For number three, the analysis will be focused on the uplink and downlink side of the transmitter and receiver. For number four, the analysis was conducted based on the calculation of link budget from uplink and downlink. Number five, the analysis was conducted by comparing the number of gateway obtained based on the use spreading factor or SF parameter SF7 and 12 on the uplink and downlink side using coverage planning and capacity planning. For number six, the analysis was conducted by comparing the result of the spreading factor, code rate, bandwidth, signal to noise ratio, and receive signal strength indicator parameter. For the next purpose are the results to be achieved in this study. For number one, knowing the distance of cell radius and estimate number of gateway need for the process of sending data in Karawang industrial area, put on coverage planning and capacity planning. For number two, knowing how to design LoRaWAN network using Atoll software based on calculation of time. And for number three, knowing the value of parameter obtained based on result of LoRaWAN network design. Okay, for benefit, provide an overview of LoRaWAN network planning using a frequency of 920 until 923 MHz by using Atoll software to be applied as a smart meter connectivity in measurement of electricity use in Karawang industrial area. For number two, provide knowledge about calculation based on link budget and calculation of the estimate number of gateway need for the process of transmitting data from end device in Karawang industrial area. For number three, with LoRaWAN network planning on the coverage and capacity is expected to provide an overview of the estimate loss value obtained during the process of sending data from the transmitter to the receiver when smart meter are used. And the last, provide an overview of smart meter performance quality comparison based on a spreading factor, code rate, bandwidth, signal to noise ratio, and receive signal strength indicator. Okay, basic theory. Basic theory is a reference that become then the basis in this study. The first basic theory discuss about LoRa and LoRaWAN. Based on LoRa radio modulation technology and In this case, LoRa used chip spectrum modulation, a MAC layer called Lorawan was aided to standardize and extend LoRa's layer of physical communication to the Internet network. LoRa is one of the lower power wide area network or LPWAN technology. Long range or LoRa is lower power remote wireless telecommunication system. LoRa is designed as an infrastructure solution to support the Internet of Things, and LoRa recognized by Semtech. Okay, in the Lorawan technology stack image, it can see that LoRa work in physical layer and LoRawan work in open network protocol that provide secure mobility and localization two-way communication service standardized and managed by the LoRa Alliance. LoRawan is intended for end device to have power limitation and only small bit of data in time interval. And this advantage make LoRawan one of the candidates for technology that can support smart sensing infrastructure such as smart metering and industrial device. Okay, Lorawan architecture. Architecture in Lorawan consists of end device or end nodes, concentrator or gateway, network server, and application server. End device or sensor, often known as mobile termination. End device such as sensor collect data and communicate with gateway with LoRaWAN technology. Communication between end device and concentrator or gateway is bridged by LoRa transceiver communication module. And the sensor that digits physical condition and environmental event. If node is mobile or moving, there is no handover need from one gateway or other gateway. This is a critical feature to enable the application with the tracking feature. Concentrator or gateway, commonly known as base station or concentrator. Each gateway concentrator will forward the packet from end device from the LoRaWAN network server. We're connected through an IP backbone or some backhaul, such as Ethernet, Wi-Fi, satellite, or cellular. In here is no fixed association between end device and a specific gateway. Instead, some end nodes can be served by multiple gateway or sensor, gateway on concentrator. For the next network server or NS routes data from the end nodes to the associated application server and respond to the sensor. And then application server can display data to user using user-friendly interface. End node is a sensor such as microcontroller, Arduino, Raspberry, or mini computer. And in network server, can use Antares, ThinkSpeak, or Blink, and the application server can use HTTP, MQTT, and CoAP. Okay, for the next research parameter. In this study, the parameter used consists of spreading factor, bandwidth, code rate, SNR, and RSSI. Spreading factor. SF is the ratio between rate and chip rate. Okay, spreading factor or SF decides on how many chips the carrier of the data are sent per second. In this picture, comparison between SF, bitrate, energy or time on air, and distance. We can see that the greater of spreading factor value, the time on air will be increased and marked with a line that is getting to the right. but the bitrate be decreased. So that higher spreading factor increase signal to noise ratio or SNR, sensitivity and range, but also increase time on air. If using low spreading factor, the time on air is minimized so that it can extend the battery life and has a high data rate. Whereas if using higher spreading factor, allow the gateway to connect with end device at a longer distance. SF7 is the low spreading factor that has highest data rate because more chips are sent per second. Parameter number 2 is bandwidth or BW. BW or bandwidth is frequency with transmission band to modulation LoRa data signal for Vmin, Vmax. In higher bandwidth provides higher data speed, resulting in shorter time in the transmission process but lower sensitivity. And use lower BW has high sensitivity but lower data speed. Number 3, coding rate. Coding rate is number of bits containing data or information to transmit. CR 4 per 4 plus N. N is 1, 2, 3, or 4. Coding rate is formulated to handle packet error rate or pair to interference. Packet error rate is used to test the performance of an access terminal receiver. Pair is the ratio in percent. Receive signal strength indicator or RSSI indicates the receiving power of all signal on the frequency band of the channel used. If the RSSI value is closer to 0, then the signal will be better. For number 5, signal to noise ratio or SNR, signal power received by the user with noise. The greater value of SNR, the greater the power obtained by the user. Okay, for the next, smart metering. The smart metering is a system that can measure, collect, analyze energy distribution and its consumption, and communicate with metering device on schedule on demand. By using the smart metering service, user can check use through their smartphone and web browser. Utility office also can check electric usage in real time for them know right away if there is a problem. Customer data collection can Lorawan, Internet of Things network connectivity, and then utility or third-party data reception and management. Okay, coverage planning. For number 1, calculating sensitivity value. LoRa sensitivity calculation based on the use of spreading factor and SNR. Sensitivity SF mean 174 plus 10 log BW plus 6 mean SNR limit. Link budget TX power minus sensitivity. Link budget is required to know the estimated loss that will occur when the signal propagates from transmitter or receiver. Maximum allowable path loss or MAPL. This MAPL is the highest attenuation value allowed than the LoRa gateway and the end device. Okumura-Hata propagation model. Oh yeah, EIRP, effective isotropic radiated power value transmitted by the antenna to produce the peak of power observed in the maximum radiation direction of antenna reinforcement. For number 4, cell area calculation. Number 5, number of gateway calculation area per cell area. And capacity planning for number 1, forecasting number of customer, and 2, spreading factor, and GF is grow factor. Number 2, single gateway capacity. Number 3, single gateway with 8 channel capacity or packet per day. Number 4, number of gateway calculation. Number of gateway, total packet transmitter per day per total packet on 8 channel gateway. And number 5, calculation of cell coverage. And number 6, calculation of cell radius. Okay, flowchart. In this study, the first step of literature we search from paper, book, website to get reference to material, calculation, parameter, and other. And then determination of location for research is based on the research background, where the location in this study is industrial Karawang area. Data collection, here to collect the required data such as electricity usage, total area and population, and then dimensioning, coverage dimensioning, and capacity dimensioning. Okay, then if simulation of coverage planning using software Atoll, analysis of planning result, and whether the planning results are based on calculation in accordance with the parameter. Okay, for the next, location of research area. Karawang Industrial Area has an area of approximately 13,756.358 hectare, or 7.85% of the area of Karawang Regency based on data from the Karawang Disnakertrans in 2018. And this area of Karawang Industrial Estate, total area, and then tabling budget Lorawan. TX power dBm for UL 5T, DL 20, TX kabel loss dB means 1 for DL minus 3, TX antenna gain or dBi UL 0 and DL 9, TX antenna height meter 30, RX antenna gain diversity dBi UL 10 and DL 0, RX antenna height meter 1.5 meter, frequency megahertz 920 megahertz, and bandwidth 125 kilohertz. Population and data device by area Karawang. Parameter area 137.56 square kilometer. Population of Karawang 2,370,488. Population of Indonesia, and estimate number of IoT device in Indonesia 400 million device. Okay, in this software Atoll is a multi-technology wireless network design and optimization platform that support wireless operator throughout the network lifecycle from initial design to the identification and optimization. Use LPWA, low power wide area network. This final project schedule or timeline, okay, for activities for number 1, literature review in February until June, proposal preparation, proposal seminar in July, preparation of required data, calculation based on linked budget table, calculation of cell area and number of gateway, calculation of number of gateway, cell coverage, and cell radius, coverage and capacity planning analysis, conclusion and completion, report session, and the last, revision and binding of report. Okay, here is a list of paper, report, and article for further reading about this topic. Okay, maybe enough explanation of the seminar proposal that I can explain maybe from Mr.